as a continuation from the previous video, let's learn more about formatting before we go and learn about other ways of input and output in C, right? So let's just focus on integer first, right? Let's just focus on integers first. Let me write some simple examples for you, right? Suppose if I have scanf, let's say I have a line like this called scanf. Let's say percentage 2D. I'll explain what percentage 2D is, right? And percentage 3D, right? And let's assume I have two variables A and B. Let's assume both of them are integer variables. Okay, I'm not writing all the steps here. If this is what I have, and there are multiple cases here. Now case 1. Let's assume I input. Let's assume, so what does this mean? This means that you will take, let me show you some examples so that you'll understand it. Suppose if I input 6 space 39, okay, then what happens? Suppose if this is the input that I give, right? Then 6 will be stored in A, right? 6 will be stored in A and 39 will be stored in B. Perfectly all right, no problems, right? Let's take case 2. Okay, I'll tell you what is this percentage 2D and percentage 3D mean with a couple of examples. Next, let's assume I input 1, 2 and let's say 1, 2, 3. I have a space in between. Now what happens? A will contain 6, A will contain 6 and B will contain, A will contain 12, I'm sorry. Now A will contain 12 because if this is the input I give, A will contain 6, B will contain 39. But if this is the input that I give, right, A will contain 12, B will contain 123. Perfectly all right. Now the third case, this is where it becomes interesting. Suppose if I give 123 and 1234 as the input, this is where things will break. Okay, because I'm using value 2 here, what it does is it only reads the first two values or the first two digits it will read into A. Now here I had only one digit, so everything worked well. Here I had only 2 digits, that's why everything worked well. But here I have 3 digits in the first number. But here what does this percentage 2D mean? It means read only the first 2 digits. Read only the first 2 digits. Read only the first 2 digits into your A. Similarly, read only the first 3 digits into your B. That's what percentage 3D means. But here if you notice, only the first 2 digits got to be read. So what will happen? A will now contain 12 because it doesn't want to read the third digit, right? Now it starts reading. So it has already read the first 2 digits into A. Now it will start reading into B, right? So these first 2 digits are read. Now it will start reading into B. Now what does it find? It finds 3 and a space, right? So the moment it finds a space, it thinks, okay, I'm done right now. So it will store 3, variable 3 or the value of 3 in variable B. Okay, so this is very interesting, right? So this is the case. There is one more case. Let me explain you one more case here. Imagine if my input is 1, 2 space 1, 2, 3, 4. Let's assume this is my input. Then what happens now? It starts reading. It will read the first 2 digits into A. So A, everything is all right. What about B? Then it starts reading B. But here it says B only take 3 digits into B. Don't take more than 3 digits. So it will start reading and it will only take 3 digits. It will only take 123. It will only take 123 into B. Okay. So this is a way of formatting input. So this is another way of formatting input to ensure that people don't enter more than 2 digits here. You don't take anything more than 2 digits here. You don't take anything more than 3 digits here. This is sometimes useful because if you think of a date, right? Think of a date. The year, if you think about the year in a date, year has to be just exactly 4 digits. Anything more than 4 digits is meaningless, right? So this type of formatting of input using, so this you can think of it as percentage ND, where N is an integer here itself, right? This N here represents the number of digits that you will read into this variable. The number of only you will read these many digits into, that's the maximum number of digits that you will read. Okay, I hope these examples gave you a good sense of how whenever you have percentage ND in scanf, how it works. And this is all about integers. We're only talking about integers right now, right? So this is one nice example. Now let's look at another example. This is as far as input is concerned. For integers, there is another very interesting case. So let me write that down. when you are generating an output or when you're printing, there is another formatting of output that is possible. Suppose if I say this, if I say A equals to, let's say I say A equals to percentage 4D, okay, and then I print a comma, let's say I print a comma, then I say B equals to percentage 3D, okay, and now I give variables A and B. Let's assume this is how I want to print. Let's take a couple of examples. Again, just like in the previous case. Imagine in case 1, A has, let's say 1, 2, let's assume A has 12 and B has, let's say 14. Okay, so when you're printing like this, the way it will actually print, again, this is called formatted printing. I'll explain you how this exactly works. This is called formatted printing. Okay, so the moment you say this, okay, the way it will start printing is this. It will print A equals to, the moment it says percentage 4D, okay, it realizes that my integer that I want to print now can be at most 4 digits. And what is the value in A? The value in A is 12. So it will place 12 here and it will leave 2 blank spaces here. Okay, then there is a comma here. So it will print comma. Then it will say B equals to. What do I have here? Percentage 3D. Right? So it will create 3 spaces. That's the max it will allow. Right? And when I have 3 spaces right now, look at this. When I have 3 spaces right now, it will try to place this 14. 14 only has two digits, right? So it will place 14 here. Okay, this is how it will work. Okay, so the output of this will look like this: A equals to blank blank 1 2 space B equals, sorry, comma, B equals to space 1 4. Not dot, this is actually space. Okay, let me just represent spaces with a blank here. Okay, this is the exact output that you would get for this case. Okay, I hope this is clear, right? So the next thing is what if, okay? So this doesn't mean exactly 3 characters. I'll show you some examples so that it's clearer. So this does not mean exactly 3 characters, okay? I think that's a small correction that I have to make for something that I just mentioned a while ago, okay? So let's take some examples. Imagine my A equals to 1, 2, 3, 4, 5, and let's say B equals to, again, 1, 2, 3, 4, 5, 6. When I print F now, how will it print? It will print A equals to, there are 4 spaces here. There are four blanks here, but I have 5 digits here. Right? Even though I have only 4 spaces here, I have 5 digits. So it will go ahead and print 5 values. Okay, this is the least number. This is not the maximum number. This is the minimum number. This is the minimum number. This is the minimum number of spaces or minimum number of positions that it will fill. Because 12 only had 2 positions or 2 digits, it is placing blank here. Okay, in this case, I have 5 digits here, while it is only 4. So I'll place all the 5 digits, right, and I'll place a comma, and I'll say B equals to, I have to place a minimum of 3 digits, but here I have 6 digits, right? So I'll place all 6 of them, right? So the correct way to understand here is this is the minimum number of characters or digits that you have to place when you're formatting your printing. Okay, this is not the maximum. Okay, I think there was a small confusion that this could be the maximum, but this is not the maximum. This is the minimum number. Okay, if you have a number like that, I think it's best to understand it with examples so that the concept is clearer. Okay, so this is one way for you to format output, right? So similarly, what we have seen for integers, now let's go on to see for floating point numbers. Okay, let's go on to see the same concept for floating point numbers. Okay, so imagine I have this. Imagine I have scanf, right? Percentage 3f. Let's assume I have scanf percentage 3f, then percentage 4f, right? And I have ampersand x and ampersand y. Let's assume x and y. Again, this is input. Remember, this is the input for float, right? This is the input for float. Now, if you notice, what does this 3 represent? Let's take a few examples. Let's go one by one. If my input is 5, 5.9, okay, everything will work well. Okay, because it's looking for 3 digits or 3 characters. Here this is looking for 4 characters. Here I have only 1, right? So the moment I give this, what happens? X will store 5.0, right? And Y will store 5.9, right? Because even though you have given 5 here, what you're reading here is a floating point number. So even though you have entered an integer here, it will read this as float. So it will convert that into 5.0 internally. Okay, this is case 1. Let's see all the cases. Okay, the second case here is if I enter 5.1, right? If I enter 5.1 and let's say 1.23. Now here it is looking for three characters. Okay, so 5 is one character, dot is the second character, and 1 is the third character. So it can take at most 3 characters. Okay, so now what will happen? X will store 5.1, Y will store, because it can take at most 4, you have 1, 2, 3, 4. Dot also got to be counted. So this also will store 1.23. Perfectly all right. Now comes the nice boundary case, right? So now let's assume I am storing 1.23, and let's assume I store, let's say, 4.5678. Now look at this. This will take only 3 characters. So 1.2. So X will store 1.2 only, not the 3. Now whatever comes next, it will start storing it in Y. So the moment it goes to Y, it will look at 3. After that I have a blank space. Okay, it will not read anything after the blank space. So Y will store 3.0 now. Okay, so the key thing here is when you are scanning both for integers, the same thing happened with integers also, right? The same logic that we've seen for integers also applies for floating point values here. Okay, I hope this is clear enough. Okay, so this percentage 3 basically implies it is the maximum number of digits or characters it will read into this variable X. Similarly, it will at most read 4 characters here. Okay, so that's one interesting thing. Now there is another. So this is, what is this format like? This is like percentage NF, right? That's the format in which these things are, right? So there is another case for floating, because floating also are decimal numbers, right? So let me show you some examples here, right? So let me show you a printf example. Let's assume I have printf. Okay, for printf I can do this, right? If I say X equals to 4.1f, comma, right? Y equals to, I'll tell you, sorry, I should place a percentile here. Okay, percentile 4.1f. Look at this. This is slightly different here. So if I say Y equals to percentage 7.2f, okay, and let's assume I'm trying to print X and Y here, right? This is also a very, very nice example. The way it works now, let's look at case 1. Okay, so let's assume my X contains, 8.0 and my Y contains 5.9. Let's assume this is the case. So when I'm printing, what would this print? Okay, look at this. This will generate an output of when I print this, let's assume these are the variable values that are there. So it will print X equals to, see, I have four spaces here, right? I have 4 spaces here. I have 4 places here, sorry. I have 4 places here. Okay, and this 0.1 basically means print only 1 digit. This point basically means print only 1 digit after the decimal point. Okay, so I have only 8.0 here. So what would it do? It would print 8.0 like this. So there are 4 placeholders and 1 placeholder will be left empty, because I have 4 placeholders here. Okay, just like in integer. Look at this. In integer, what did I have? I have 4 placeholders and I started filling from the left to right. Or right to left. Okay. Similarly, even here I am doing the same thing. So it will print X equals to space 8.0, comma. Now what about Y? Y equals to percentage 7.2f. So there are 7 placeholders. 4, 5, 6, 7. For these 7 placeholders, I will use at most 2 digits here after the decimal. So I'll use, not at most, I'll use 2 decimal places. Not at most, I'll use 2 decimal places here. Exactly 2 decimal places. So what do I have? I have 5.9. So it will start placing 5.90. Why is it doing 5.90? Because I asked it to have 2 decimal places after the dot, right? And I have a total of 7 spaces. Sorry, I should say y equals to. I have a total of 7 spaces, but 5.90 only took up 4 spaces and 3 spaces will be left blank. So this will actually print x equals to blank 8.0 comma y equals to blank 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 5.90. This is the exact output that you would get. Okay, I hope this is clear. Now let's take another example. Let's take a slightly trickier example, right? So imagine if my input is, let's say, 15.231. let's say my x is 15.231, my y is, let's say, 65.12345. now how will the output be generated in this case? So it will say x equals to, right, percentage 4.1. because it is 4.1, I'll only use the first decimal place here. I will ignore the rest of the 2 decimal places. Similarly, here you have 7.2, which means only 2 decimal places will be used here. Rest of them will be ignored, right? Since I'm ignoring the rest of them, now it says I have to fill at least 4 placeholders. And how many digits do I have here, or how many characters? 1, 2, 3, 4. So it will print 15.2 because I have 4 placeholders, comma y equals to. I have 7 placeholders now. 1, 2, 3, 4, 5, 6, 7. For these 7 placeholders, I will place 0.12 and 65 here. So 2 more placeholders will be left blank. So this will literally print x equals to 15.2 comma y equals to blank blank or space space 65.12. This is what it will print. So this is said to be in %n.m format, right? So this n represents the minimum number. This n represents the minimum number of characters. The minimum number of characters that will be printed. M represents the maximum or the number of, to be more precise, it will print the number of, right? So not the maximum, it will print these many m number of digits after decimal. It will print m number of digits after decimal. Okay, after the decimal dot symbol. Okay, I hope this is clear. Okay, so this is one way. So now let's look at, so we have seen integers, we have seen floats. Now let's go and look at strings, right? So in the case of strings, what happens is this. Okay, suppose you have a string, let's say char str10. Okay, so it can store up to 10 characters. Now if I say scanf, right? So suppose if I say scanf %s, suppose if I say scanf %s, instead of percentage, suppose if I say %s and str, if I give it a, b, c, d, e, f, if I give this as input, what does it store? It stores a, b, c, d, e, f followed by \0. This is what would be eventually stored in str. This is case 1. Very nice, that is simple. Now what if I modify this %s also? So what if my scanf looked like this? Scanf percentage, okay, let's say %3s and str. Now this 3, this is very interesting. This 3 basically implies that I will only take up to 3 characters and no more than that. That's what this means. Okay, so let's look it up. So here if I give my input, imagine if my input here was a, b, c, d, e, f. What would be stored in my str up at the end of this? It will only store a, b, c. It will only store the first 3 characters and it will store \0. It will ignore d, e, f. Because this says that I want to take only 3 characters and no more than that. Okay, so this is one way of formatting. So this is one way of formatting input. So this is input formatting. This is input formatting of strings. Similarly, there is an output formatting of strings. Okay, let me give an example of how it works. Suppose, imagine if I have printf. Okay, printf, let's say %3s. Okay, and if I have, let's say, a string, let's say a, b, c, d, e, f. What would this actually print? Right? If I have %3s, okay, it will print at least 3 digits. If there are more than, or 3 characters I should say, if there are more than 3 characters, this will actually print A, B, C, D, E, F. No issues here. Okay, let me give another example. Imagine if I say printf, right, percentage, let's say 5s, and if I give just a string which is AB, what would this print? Okay, because I'm asking it to print at least 5 characters, but there are only 2 characters in the string. So what would this print? This would print space, 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 right? This would print space, 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 and AB. This is what it would print. Because AB does not contain 5 characters, it will fill the first 3 characters with blank or space. Okay, this is the other example. Now let's take another very interesting example here, right? This is also very interesting example. So imagine if I have printf, right? Imagine if I have printf percentage dot 3s. Okay, let's assume I have percentage dot 3s. Okay, and let's assume I have A, B, C, D, E, F. What does this print? Okay, look at this. This is percentage dot 3. Okay, so this is important. This is dot 3s. Let me change the color here. So what would this print? This would only print the first 3 characters, exactly the first 3 characters. So this will print only A, B, C and nothing after that. So the dot basically, just like in float, if you recall, what does float do? Look at this example. What does float do? Whatever you have after dot, in this example, it will only print 2 decimal places. Everything after that it ignores. Similarly, in strings also, you could have percentage n dot m format. Sorry, m not f. Percentage n dot ms. Right? So the first one represents the minimum number. The first one represents the minimum number of characters to be printed. The second one represents the maximum number of characters to be printed. Okay, so let's take another very interesting example. Suppose if I have printf, let's say I say percentage 8.3s. Okay, suppose if I say percentage 8.3s, and if I say A, B, C, D, E, F, what does this print? Okay, let's look at. So percentage 8, the first thing says I want to print 8 digits or 8 symbols or 8 characters, 4, 5, 6, 7, 8. But the second one says that you can only print 3 characters in this and no more than 3. Okay, so what would it do now? It would actually place A, B, C here and place everything else as blank. The first 5 placeholders, it will place them as blank. And it will only take, because it has dot 3 here, right? So the dot represents the maximum number of characters to use from this variable. Okay, so the first one says the minimum number of characters you want to have in the printf. So what this is a tricky case, right? The percentage 8 says I want to print 8 characters. I have placeholder for 8, but I want to use only the first 3 in this constant. Okay, so I'll only print ABC ignoring DEF here, right? This is also a very interesting case. So since we have seen, see what all have you seen now? We have seen how integer, input works with percentage n dot, with percentage nd format. This is integer input. This is integer output. We have also seen integer output. Sorry, where is integer? This is integer output. Again, this also has percentage nd type of format. Okay, we have seen floating input, right? Floating input has percentage nf type of format. Floating output has n.m format. Similarly, string input, right? String input. So we have seen string input where we had percentage ns as input, and the output is n.ms. Okay. The simple way I always remember is whenever there is dot, right? So both string and float start behaving very similarly because only they both have n.m format. Right? Your integer only has n, percentage nd, right? So all these are about formatting outputs in whatever way we want for different types of variables, right? So there is another very interesting concept called suppression characters. There is another concept called as suppression characters, right? The way they work is this. It's a very simple example, right? So imagine if I want to, let's say, just as an example, right? Suppose let's assume I want to input something. Let's assume I say scanf. Okay, I'll explain you the suppression characters in detail here. Let's assume I say scanf. percentage D, okay, then percentage star D. This star is what makes this a suppression character. Percentage star D, okay, then again percentage D, okay, and let's assume I have three variables, A, B and C. Let's assume all of them are integer variables and I'm trying to use these as input there. Okay, now what happens? Let's look at each of these cases, like for scanf. Now suppose if I give an input like this, if I give 25 space 30 space, let's say 35. Okay, so what this means, this is a very nice case actually. What this means is when you take percentage D, so what does it do? It starts reading for an integer. So it read 25. So it will place 25 in A. So A now will become 25. Okay, that's very nice. This percentage star D, basically this is called the suppression character, which means whatever you enter, whatever decimal or whatever integer you enter now, just ignore that. Just ignore that. So it will ignore the next integer that you have input, which is 30. It will simply ignore this. It will simply ignore this. Next decimal place that you input, okay, which is percentage D, which is 35 now, right? So it will store 35 in B, right? So it stores, because we have ignored this input, right? So 25 went to A, 35 went to B, and there is no other input left for C. Okay, because literally what is it saying? It's saying don't take the second integer that I give, just ignore that or just suppress it. That's why it's called the suppression character. Okay, the second integer I give, just suppress it, don't use it at all. Okay, now what happens to C? What is stored in C now? That's a good question. So when you declare a variable, imagine you declared a variable int C, or you declared a variable, you didn't store or you didn't initialize it with anything. What happens is C will not be left empty. There will be some random number, there will be some random integer, okay, also called as garbage value. Okay, in computer science and programming, this is often referred to as garbage value. Some random number, some random integer will be stored here. So now if you try to print ABC, you'll get 25 as output for A, you'll get 35 for B, you'll get some random number for C. It could be any number, 1, 2, 3, 4, some random number. Okay, so the key thing here is if you mention this, if you have an input like this, what it does is it suppresses the second integer that you have input. Okay, very simple. Now there is a slightly other way of, so we have seen printf and scanf till now, right? So we have seen printf and scanf till now. There is an other way to read. It is called as getchar and putchar. Okay, so these functions are called as getchar and putchar. So they're useful to, as the name suggests, you can input just a single character using getchar. You can output or you can print a single character using putchar. Let me give an example. Imagine I have a character C, right? Now I can say printf, right? Sorry. So now I can say printf. Let me erase this. I think that's a spelling mistake there. I can say printf, enter an alphabet or enter a character. Okay, I can say enter a character. Okay, now instead of using scanf, I can say C equals to getchar. So when I say C equals to getchar, this will behave exactly like, scanf percentage C, right? Percentage C ampersand C. This will exactly behave like this. So it will get one character from the standard input, which is your keyboard, and place it in C. That's what it will do. Similarly, this is your getchar, right? Similarly, putchar also does the same thing. I can say printf. Suppose let's assume I enter A here. Okay, suppose from the keyboard, let's assume I enter A. Now what happens? A is stored in your variable called C. Now if I say printf, okay, the value you entered, the value or the character you entered, right? If I say the character that you entered is, okay, suppose if I place this, and now if I use, instead of printf, if I say putchar and C, it will actually print this A here. Okay, so the output here will say the value that you entered is semicolon A. Okay, so getChar and putChar are two other input output. These are part of standard IO. So these are available for you for character input and character output. You cannot get strings or anything else using them. You can only get single characters from them.